Welcome to the Unit 4, Section 2 video on key features of linear functions. The slope of a line in a coordinate plane is a number that describes the steepness of the line. Reading the graph from left to right, there are four types of slope. You have positive slope, negative slope, zero slope, and undefined slope. One way to find the slope of a line is to examine the vertical and horizontal change between 2 points on a line. So in a positive slope, you're going to have an increasing line from left to right. A negative slope will feature a decreasing line from left to right. Zero slope is a horizontal line, and undefined slope is a vertical line. Sometimes the vertical distance is referred to as rise, and the horizontal distance is referred to as run. The ratio of rise to run is called slope. So the slope m of a line is the ratio of the change in y to the corresponding change in x. So slope is change in y over change in x, or we can write it as m equals change in y over change in x. The letter m, or the variable m, is representative of slope. On a graph, the line passes through the origin, 0, 0, and the point 4, 3. The change in y, or rise, is 3, while the change in x, or run, is 4. Therefore, the slope of the line is 3 over 4 because we use rise over run. So to find the slope from a graph, you make a triangle to connect 2 points on the line. You can use only vertical and horizontal lines. Count the number of boxes up or down. This is the rise. Positive movements are up, negative movements are down. Count the number of boxes left or right. This is the run. Positive movements are to the right, negative movements are to the left. Write the rise over run as a fraction and simplify. So we're going to find the slope of the line of this graph. So to do this, we see that we go down 1 and right 3. So we have negative slope, and we do our rise over run, 1 over 3, and since the line is decreasing left to right, it is going to have negative slope. The slope of the line can be determined when given the coordinates of the points are listed in a table. So here are some points listed in a table. We plot those points, we draw our line through it, and then we can use rise over run to determine the slope. Our change in y is 3 because we go up 3, and our change in x is 2 because we go right 2. Any 2 points on the line can be used to determine the slope. So the slope of a line containing 2 points with coordinates x1, y1, and x2, y2 is given by this formula, y2 minus y1 over x2 minus x1, where x1 cannot equal x2 because you cannot divide by 0. So we're going to, in this example, find the slope of the line that passes through the points negative 3, 4, and 8, negative 7. So you use your slope formula, and you put in y2, which is negative 7, minus y1, which is 4, x2, which is 8, minus x1, which is negative 3. So yes, on the bottom we have minus a negative 3. Make sure you take care of your signs as you work these carefully. On the top, negative 7 minus 4 gives us negative 11. On the bottom, 8 minus negative 3, which is the same as 8 plus 3, is positive 11. So our slope is negative 1. In example 3, we're going to find the slope of the line passing through the points 4, 9, and 15, 9. So again, y2 minus y1 over x2 minus x1. Our y's are both 9 and 9, and our x's are 15 and 4. So we have 9 minus 9 over 15 minus 4, which gives us 0 over 11. 0 divided by 11 is 0. So this is a 0 slope, which would indicate that we would have a horizontal line. Find the slope of the line that passes through the points -13, -8, and -13, -17. So in this case, we do our rise over run, our y2 minus y1 over x2 minus x1. And we find that we get -9 over 0. But x2 and x1 cannot be the same because that gave us division by 0, which is undefined. So in this case, you would say that our slope is undefined. If we were to graph those points, we would find that the line going through them would be a vertical line. In the last unit, we talked about key features of functions. Now we're going to specifically talk about key features of linear functions. Slope is a key feature that is unique to linear functions. You already learned several other key features of functions that can be applied to linear functions. So let's go through the list of them. The x-intercept is the point where the graph crosses the x-axis. The y-intercept is the point where the graph crosses the y-axis. The domain is the set of all x values, while the range is the set of all y values. Your positive interval is a set of x values with positive y values, or in other words, where the graph is above the x-axis. Your negative interval is where the graph is below the x-axis, or where your y values are negative. Your increasing interval is the set of x values where the graph increases left to right. Your decreasing interval is a set of x values where your graph decreases from left to right. And your slope is the steepness of the line given as rise over run. Note there are some unique characteristics of some key features for a linear function that is not constant. There will always be exactly one x-intercept and one y-intercept. The domain and range will both always be negative infinity to positive infinity. The function will either always increase or always decrease. There will be exactly one positive interval and one negative interval. For end behavior, f of x will always approach infinity on one end and negative infinity on the other. For end behavior, look at the right and left ends and determine if the graph is going up or down. So here's a quick review of end behavior. So in this graph, as x approaches infinity, so we're going to the right, f of x approaches infinity because we're going up. And then going on the other side, as x approaches negative infinity, going to the left, f of x approaches negative infinity because the graph is going down. So let's do a couple of examples and determine some key features of a couple of graphs. So in this graph, we start off with the x-intercept, which is located at 6, 0. The y-intercept, where it crosses the y-axis, is at 0, -3. Your domain is going to be negative infinity to positive infinity. Your range is also going to be negative infinity to positive infinity. Both domain and range for linear functions will always be this. Your positive interval, there's only going to be one of them, and it's from 6 to infinity. Your negative interval is from negative infinity to 6. Notice that your positive and negative intervals cut off at the x-intercept. We are always increasing because the graph is always going up from left to right, so negative infinity to positive infinity. We are never decreasing. Our slope is 1/2 because our rise over run is 1 over 2. We go up 1 and to the right 2. Our end behavior, as x goes to infinity on the right side, our graph is going up, so f of x is going to infinity. On the left side, as x goes to negative infinity, f of x is also going to negative infinity because our graph is going down. In this graph, our x-intercept is at 2, 0. Our y-intercept is at 0, 4. The domain and range always going to be negative infinity to positive infinity. Our positive interval cuts off at the x-intercept, 2. So it is above the x-axis from negative infinity to 2, and below the x-axis from 2 to infinity. This graph is never increasing because it is always decreasing. Our slope, our rise over run, is going to be negative because the graph is decreasing. We go down 2 and to the right 1, so our slope is negative 2 since our rise over run is negative 2 over 1. And our end behavior, as x approaches infinity on the right, our graph is going down, so f of x goes to negative infinity. As x approaches negative infinity on the left, f of x is going up to infinity. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.